4 rules for prompt engineering that hold up in production. 1. Write evals before you change anything, control, edge, and boundary cases. 2. Structure the prompt with XML tags. If you cannot parse it, neither can the model. 3. Delete old defensive instructions when you upgrade models. Patches written for earlier models break on newer ones. 4. If a task needs arithmetic or a handoff, give the model a tool or an escalation path. Instructions alone cannot add that capability. Apply these 4 in order. Skip step 1 and you cannot tell whether anything else worked. Anthropic engineer Margot Vanlar just ran the prompting playbook on a real production prompt. This is Liam. 2 scenarios, a prompt that broke on migration and a new agent built from zero. Same 4 steps apply to both. Here's what they are and when to use each one. 2 scenarios engineers face constantly. First, a prompt in production with multiple contributors, no clear owner, and model migration breaking test cases. Second, a new agent from scratch with no baseline. The discipline is the same for both. You need a reproducible test suite before touching anything. Without one, every change is an experiment with no control group. 3 categories of eval cases, all required. Control, an unambiguous query the model should always pass, confirms nothing broke. Edge cases, queries where the model has failed before, the prompt now catches them explicitly. Boundary, queries the model should refuse or escalate, tests whether it knows the edge of its role. Missing any category means your eval suite has a blind spot. Run these before and after every prompt change. General cleanup before targeting specific failures. Rule, if you cannot tell guidelines from policy from data in the prompt, the model cannot either. Fix XML tags, role, guidelines, policy, tone, customer context, user message. That single structural change improved a failing test case before any targeted instruction was written. Also, add a stop sequence. A closing XML tag as the stop signal prevents runaway output. This matters most with structured or nested schemas. Patch det, an instruction written to stop a hallucination on one model causes a different failure on the next. Example, never give wrong plan details, point to the URL. Written to stop hallucination on v1. On v2, followed literally, model withholds correct information already in context. When to apply this rule, at every model migration, audit every defensive instruction. Check why it was written. If the original failure no longer occurs, delete the patch. Instructions do not add capability. Critical, always calculate proration correctly does nothing. The model cannot do reliable mental arithmetic. The solution, register a tool. Add the proration calculator to the API call. The model calls it when needed, reads the output, explains the result. When to use a tool versus an instruction. If the task requires exact arithmetic, deterministic lookup, or external state, use a tool. Instructions only change behavior within capabilities the model already has. Give both sides of every trade-off in the prompt. Avoid escalating. It costs $8 per case. Produced a model that never escalated, even on genuine billing errors. The model optimized for the goal it was given. The fix, state what not escalating costs 2, refund plus customer trust. Apply this everywhere you are telling the model to avoid something. More capable models optimize trade-offs more aggressively. An incomplete cost function produces stronger wrong behavior. 3 levers model prompt harness. Staff scheduler, hard constraints, 5 trials each. Sonnet 4.6, simple prompt, all fail. Opus 4.7, same prompt, violations drop, still failing. Opus with extended thinking, compliant but triple tokens and triple latency. Sonnet 4.6 with a better prompt, 2 of 5 pass, hits output limit. No single lever solved it. Test all 3 before concluding the model is the bottleneck. 3 single responsibility prompts outperform 1 large prompt for constrained optimization. Generator drafts the schedule. Evaluator checks every hard rule and reports violations with evidence. Repair makes targeted fixes to violations only. Result, lower token count, lower latency than an enlarged single prompt. Bonus, soft constraints go into the evaluator at runtime, no code changes required. Use this pattern when the task has discrete separable steps with clear pass or fail criteria. Your turn, take a prompt you own. Write 5 test cases, 1 control, 2 edge cases, 2 boundary cases. Run it before changing anything. Find the first failure mode. Apply 1 change, structure first, then a targeted instruction, then a tool if instructions fall short. Measure whether the failure count went down. Paste this into Claude to generate the eval suite. The Prompting Playbook, Humanitarian's AI.
Humanitarian's AI.